Okay, question 12. There seems to be a lot of words here. So let's break this down. Okay. We have Shalom wants to determine the height of a cell phone tower that is supported by a guy wire. Not gonna lie, don't know what a guy wire is. She finds that the guy wire makes an angle of 53 degrees. Well, must be this. Guy wire must be this then. Okay. Makes 53 degrees with the ground and is attached to the ground 65 feet from the base of the tower. Okay, thank goodness we have a picture. Okay, let the height of the tower be x. So that's going to be this. Okay. So which trig ratio should we use to write an equation that you can solve, right? And solve the equation for the height of the tower. Round the nearest. Okay, so again, trig ratios have everything to do, everything revolves around the reference angle, in this case our 53 degrees. So that means x represents our opposite side, okay? And 65 represents my adjacent side because my hypotenuse is across from the right angle. So opposite over adjacent, that means I need tangent. That's going to be my tangent function. Okay, so we're looking for x. Now, when we're solving for a side length, remember I showed you guys we're going to put the tangent of 53 over 1 and we're going to cross multiply. I like to create a proportion. I personally think that's easier. If you want to multiply both sides by 65, if you see it that way, if you can see that to get x by itself, I need to multiply both sides by 65, that's fine too. Either way, we're going to end up with the same answer. So when I cross multiply, I'm going to do x times 1 and 65 times the tangent of 53. So tan 53 times 65. So the tangent of 53, you're going to get either from your trig table, which is your 4-digit decimal, or on your calculator, simply push the tan button and then 53 and hit equals. And you will get a decimal of 1.327. Okay, so the height of our tower is going to be 1.327 times 65. So it's going to be approximately 86 feet high. Okay, if you're a little over, a little under, that has to do with rounding, so don't worry about that. But you should get something close to 86 feet. Okay. Next, suppose Shalom had wanted to find the length of the guy wire. Okay, so in that case, the guy wire is this length from R to S, based on our word problem, okay? And that happens to be our hypotenuse. And we have the 65. So we're looking at 65. Again, everything revolves around the 53 degrees. We said that our 65 feet side or along the ground is adjacent, and the guy wire represents the hypotenuse. So adjacent over hypotenuse, this is going to give me cosine. Okay, cosine of 53. Okay. Now this time, because I am solving for a length that's in the denominator, I'm going to end up dividing, okay, as my last step. So when I cross multiply, what I get is when I cross multiply, I'm going to go y times the cosine of 53 equals 65 times 1, which is 65. To solve for y, I need to divide by the cosine of 53 to get y by itself, and those cancel each other out. So in the calculator, what you're going to type in is 65 divided by cosine 53, and that will give you the length of the guy wire. And when I punch that in, I get 108 feet. And till I scrolled down, I didn't even notice. So this would be our answer here, 86.3. And then, of course, we got 108.1.0, sorry. Okay. All right, next one. Okay, this one, again, is already laid out for us by the picture. We got Esther's flying her kite. Her string's 29 inches meters, and she is 1.75 meters tall. How high is the kite from the ground? Okay, so from the ground. So technically, we're trying to find this measure here, okay? But first, we can find the height of the triangle from the end of the string first, okay? So label your triangle. Opposite, this is hypotenuse. So it means I'm dealing with, so that's the sine function. Sine function of 29 equals my opposite side divided by my hypotenuse, which also happens to be 29. Put this over 1, cross multiply, I get x is equal to 29 times the sine of 29. And you can plug that into your calculator exactly like this. 29 times the sine button of 29, and I get 14.05. Okay. Well, actually, if I was to round, I get 14.06. Sorry. Okay. So that's this length here. This is 14.06. Okay. And thankfully, our picture tells us that she is 1.75 meters off the ground. So if I add 14.06 plus the 1.75, I will get the total height the kite is off the ground. 14.06 plus 1.75 gives me 15.81 meters. If at any reason I've gone too fast through this, just be sure to touch base with me, and I'll go over anything or any questions that you might have. Okay. All right, here, what do we have? Solve for the side of LJ, okay, and then angle K. Okay. Well, we already know that the three angles of a triangle add to 180 degrees. So if I just subtract 90, which obviously gives me 90, and I subtract 35, I'll find what K is without doing any trig at all. So this is 5. So yeah, so angle K is 55 degrees. I mean, you could and can, once you find the side length of LJ, you can use the two side lengths to find the angle of K, but you don't have to. You can just do the simple subtraction. So to find the length of the triangle, okay, label first. So I got 35 degrees. This is opposite. Right angle's here, so this is my hypotenuse. And so that makes X my adjacent side. Okay, so that means I'm looking for the adjacent side. I have the length of the opposite side, so that means I'm going to be using my tangent function, because I don't have a length of the hypotenuse, so I can't possibly use sine or cosine. Now just remember, tangent is opposite over adjacent. So that means 15 has to be on top and x has to be on the bottom. You can't interchange those. Okay, then this looks similar to our other problem. I have a length I'm solving for is in the denominator, so I'm going to end up dividing, because 15 times 1 is 15, and then x times the tangent of 35. So to solve for x, I actually have to divide both sides by the tangent of 35. So in your calculator, just do 15 divided by, then hit tan 35, and we get 21.42. Of course, they rounded, so we're good there. Okay, next question, let's see here. Explain how you can use ratios of the side lengths to find the angle measures of the acute angle. Okay. All right, so let me do 16 first and go back to 15. And I'll show you why. So this way you can at least follow the steps with me, and then we can fill in the words. Might be a little bit easier. So if I'm looking for angle E, okay, I don't know what the measure of angle A is, but that is my reference angle. So 4 is opposite, 6 is opposite the right angle, so this is my hypotenuse. So I have opposite and hypotenuse, and so that's going to be my sine function. So the sine of E is the opposite side of 4 divided by 6. Okay. If you're using the trig table, you're going to do 4 divided by 6 to get that decimal. And you're going to want 6 decimal places. I'm sorry, you're going to want 4 decimal places to ensure you get as close and the most accurate angle measure, which happens to be just 666 repeating. Now, if you're using just the calculator, we would have to use sine to the -1. And to get that, we have to hit the second button first, and then the sine function, the sine button. This indicates the calculator to not give me the ratio, but to give me the angle measure, okay? So I'm going to hit second, then sine, and then I'm going to actually do the division. 4 divided by 6. And I get an angle measure of 41.8 degrees. Okay. So we labeled the triangle to determine which values of the triangle I had. Was it the opposite side, the adjacent side, or the hypotenuse? And then, based on which side lengths of the triangle I had, I was able to determine which function to use. And remember, and this is because we use -1, this is considered the inverse function, okay, or the opposite, okay? So let's see if we can go back and figure out what the wording here that they're looking for. All right, so explain how you can use the ratios of the side lengths to find the angle measures of the acute angles in a right triangle. To find the blank ratio of an acute angle, you can find the ratio of the adjacent side to the hypotenuse. Okay, so adjacent. Okay, and this is the side length. Okay, this is where the key words are. side length. So for the side length, adjacent to hypotenuse, that's cosine. Okay? To find the measure of the acute angle, which we just did, we're going to use our calculator to find, I'm assuming this is the same problem. If we have adjacent hypotenuse, we're going to actually use the inverse cosine, because that's the cosine to the -1. That's what we call that. We call that the inverse function. It's just the opposite, because when you hit the sine, cosine, or tangent buttons on the calculator, you're asking the calculator to give you the ratio, the decimal of the fraction, the decimal in which we can convert to a fraction to determine those lengths of those adjacent sides and hypotenuse. When we're looking for the angle measure, we don't want the calculator to give us the ratio. We're giving it the ratio already, like we did here. We gave it the ratio 4/6. So we need to let the calculator know we want the actual angle degree, that we're not punching in the angle degree. We're actually punching in the ratio. So that's why we do the reverse.